So we did this in the two-dimensional unit, and now we get to do it in 3D. I say get to because I think this lesson is so fun and real-world applicable. So on Tuesday, all of our figures, all of our solids were what? If we wanted to use our PAV ratio trick, that stands for perimeter area volume, where we had 1D, 2D, 3D. And when I call it a trick, the reason I'm calling it a trick is because we didn't have to touch our formula charts. We were dealing with cylinders and prisms, but we didn't even look at the formula for them. So yeah, if we want to use our trick, the figures have to be, both of those answers are right. Very good. They had to be similar. They had to be proportional. Today, we're doing non-proportional change. Our figures will not be similar today. Name two solids that we have been studying that are always similar no matter what. Hatham got both of them, yes. Cube and sphere. Oh wait, I'm skipping around. So you can't possibly take a cube, make a new cube that's not proportional to the first one. A cube, since all of its sides have the same length, all of its edges are congruent, you can't possibly make it non-proportional. And a sphere doesn't have a base, it doesn't have a height, it only has an R. So there's absolutely no way to make a new sphere that's not similar. So all spheres are similar to each other, and all cubes are similar to each other. All right, so let's find out, what is it going to sound like today when our figures are not similar? How is it going to be different to what we did on Tuesday? So let me give you some different scenarios that you're like, oh, okay, that's today's lesson versus, oh no, that one I could use my trick on, okay? These are ones you would not be able to use your PAV trick. Example. Double the height of a prism, but not the area of the base. So you double the height of the prism, but you don't touch the area of the base. So like if you were finding the volume, and on our new one, the volume would equal sorry. So if you do that, you double the volume. That doesn't use the 2 to the third thing. That just means, oh, I doubled the height. All I did to the volume was double the volume because I didn't touch the base. Add 3 to a cone's radius, but keep the same height. When you add, so on this one, when you are adding, that is not a scale factor. That's not a factor. So you're not creating a similar solid. You're creating a new solid, but definitely not similar. What would that look like? So if I did volume here, 1/3 pi r squared h is the volume of a cone. If I added 3 to the radius, oh my gosh, weird things would happen. It'd be 1/3 pi r plus 3 squared h. Heaven's sakes, that would not be similar to our original one. Not even close. Ooh, horizontal stretch. Okay, all right. The last example I have, let's triple a pyramid's base area, but half its slant height. So let's say I was doing surface area here. If I was doing surface area, what's the surface area of a pyramid? I believe that's it, right? So if I tripled the base area, that'd be plus 3b, but I halved its slant height, the new one would look like that. Yeah. So what I'm trying to get at here is that there's no trick today. Today, you have to touch your formula chart, you have to use the formulas that actually match the shape that you're given, and then you have to do what I call formula manipulation. You have to manipulate the formula to see what happens, okay? And it's not as scary as it sounds. That sounds scary, formula manipulation. Sounds a little scary. All right, let's look at these examples and let's sort them into, I know I love not using a formula chart too, I know. Let's sort them into, oh, these would be proportional, I can use my trick. Oh, these are not proportional, don't touch the 1D, 2D, 3D thing, okay? Let's start with this one. Proportional or non-proportional? Similar or not similar? If you only use a factor on one of the dimensions, then you produce a figure that is not similar to your original one. Not proportional. Okay, let's do this one. We already talked about this, right? All cubes are similar. So I am multiplying my side by 4. In effect, I'm really multiplying all the dimensions by 4 because it's a cube, therefore it's proportional. I'm doing the same to everything. All right, next one. This one's scary. Not scary. This one's debatable, right? You're kind of like, ooh, you're on the fence. You're like, we added, and she said not to add, but we did it to every dimension. No. So to be proportional, you have to be multiplying by a factor. It has to have a scale factor. This one would not have a scale factor. It's X, Y, and Z, so it's not a cube, because I named them different things on purpose. So it's not a cube, it's a rectangular prism. So this one's not proportional because you're adding. That's bad. Okay. Last one. Is it okay to divide? Does that work? Because dividing by 2 is the same as multiplying by 1/2, right? Yeah. So my scale factor is 1/2. I did it to every dimension. I did it to the height and to the radius. So I'm good to go. I am similar. I stayed proportional. Okay? So now that we know what it looks like to be proportional and non-proportional, let's do the formula manipulation that I was talking about. It's not too bad. Okay, so I take a cylinder. I only double the radius. Look at those two solids. You can tell right away those are not similar, so I can't use my shortcut. How will the volume be affected? So it's saying, if you double the radius, what do you do to the volume? And are the cylinders still similar? And we know, we totally covered this. No. All right, so this is what I call formula manipulation. Do it with me. What you need to do first is write down the formula for volume of a cylinder. I don't want you to write down base times height. I want you to go ahead and write down the formula with the actual correct base. Oh, sorry. Kind of important. Pi r squared h. Alrighty. So that's our original one. That's the volume of the original cylinder. I'm going to do volume subscript 1. Volume sub 1. Now let's see what happens. Volume sub 2. With our new cylinder. I need to double the radius. So instead, in my formula, instead of R, I'm going to write, you got it, 2R. The last thing you do is you clean up your formula. You want it to go in order. You want it to go with like coefficient and then pi and then the variables, okay? So if we clean this up, we get pi. 2 squared is 4. R squared is R squared. There we go. And then we can reorganize it. Then you ask yourself, the whole answer to the question is, how does the new volume compare to the original volume? Good. It's 4 times greater. So if you double the radius of a cylinder and you don't touch anything else, then you will quadruple the volume. If you double the radius, you'll quadruple the volume. That's the answer. Okay, let's try and see what happens. New picture. Now we're not going to touch the radius. The circles are congruent. I'm only going to double the height. What happens to the volume? Yes, Hatham, stop giving it away so quickly. So the only difference in the two volume formulas is that coefficient of 2 out front. Oh, y'all are so funny. So I double the radius, I quadruple the volume. I double the height, and I only double the volume. Why? Why did I affect the volume more in the first one than the second? No, because circles are complicated. So the formula for volume looks like this. That's really like saying this. When you double the radius, since there's 2 radiuses in the formula radii, I know, you're getting more bang for your buck. You're doubling the radius, but radius makes 2 appearances in the formula. When you double the height only shows up once, therefore you don't get as much bang for your buck. Okay? So that's why it's different. Last part of this. If the radius and height of the cylinder are both doubled, how will the volume be affected? Don't do it. Don't do the formula. Yeah, because in this one, the cylinders will be similar. So we're going to do our little trick that says I'm doubling the dimensions. I need to make it 3D because it's volume. So all we're going to do is 2 cubed. We're back to Tuesday. We just time traveled. 8 times bigger. Cool. Super fun. Okay, I know y'all don't drink coffee. Let's pretend this said hot chocolate, all right? Your hot chocolate thermos holds 3 cups of hot chocolate. Your friend's hot chocolate thermos is twice as tall, a lot taller, but half the radius of yours. How much coffee, how much hot chocolate does their thermos hold? So what I want you to take away from this lesson is that there's no shortcut and there's no trick, okay? You were right. Yes, Sharon. Okay. There's no shortcut. There's no trick. You need to take the formula and see what happened to the formula. So we are going to assume these are cylinders. I understand they might not be perfect cylinders, but we're going to assume. So we're holding liquid. We're holding liquid. So it's not LA, it's not SA, it's volume. So we've got the same formula we were using on the other page. Pi r squared h versus pi, twice as tall, so there's no h anymore, there's 2h, half the radius. Yikes, I barely fit that in there. We did 2 things. We halved the radius and doubled the height. You need to clean up that formula. You need to combine like terms. 2 times 1/4. So you're comparing those. Pi r squared h became 1/2 pi r squared h. So even though their thermos is so much taller than yours, your radius really gives you a lot more coffee. So if yours holds 3 cups, then theirs would hold, oops, I got too excited. There we go, 2. 1/2 times 3 cups. So yours holds 3 cups, theirs holds only 1.5 cups of coffee. They're going to be less caffeinated than you are. Next problem. When inspecting 2 tissue boxes, because I'm sure you inspect them all the time, you notice that one has half of the height and triple the width. How do the volumes compare? Who wins? Who holds more tissues? Okay, so what shape are we dealing with? Oh my gosh, people. Oh my gosh, stop typing the answer. We are dealing with prisms. The volume of a prism is area of the base times the height. Well, I don't have to write it twice. All right, so if we call the first one base times height, what would we call the second one? Well, the height part is easy. We halved the height. So instead of h, I'll write 1/2 h. what did I do to capital B when I tripled the width? Did I triple the area of the base? Now, if you're concerned and you're like, ooh, I don't really know what I did to B, because that's not W. So if you're concerned, you can draw a picture. I'm going to try to triple the width. There we go. So in this picture, B would be length times width. In this picture, B would be length times 3 width. So really all you changed was you did triple the area of the base. That's what you did. Okay, so it's area of the base times the height versus 3 times the area of the base times 1/2 the height. Clean it up. Final answer, how do the volumes compare? This one has 1.5 times more volume, or 3/2 times more volume. Okay. A gift box has dimensions 6 by 8 by 12. If we cut the height in half, but add 4, whoa, this is new. We're not multiplying by 4, we're adding 4 to the width. How will the surface area and volume be affected? Remember, there's no shortcut. You simply have to find the surface area, find the new surface area, and compare them. There's no shortcut. All right, so I want everyone to find the surface area of this one right here. Don't type it yet. Everyone find the surface area, please. So yeah, it is hard when we use the word width, like which one is the width? The great news is it doesn't matter which one you want to call the width. It doesn't matter. But yeah, so if we want all of our work to look the same, if we want to have the same process, then we can do length by width by height. We can do that. It won't matter which one you choose to be the length, which is cool. So the surface area of this prism is 432. All right. Now let's talk about our new prism. Our new prism. Do my best here. Okay. So we didn't touch the length. We're adding 4 to the width. And we are cutting the height in half. So now please find the surface area of your new prism. So the surface area of this one comes out to, what did we say, 376? So here's the weird part. It said, how will the surface area be affected? And there's really no good answer. I want you to do 2 things each time. First, I want you to subtract them. So 432 minus 376. How is it affected? It was affected, it's 56 square centimeters smaller. So that was us subtracting. Then I want you to divide them. 376 divided by 432. It is 0.87 times smaller. So our first one is how the surface area, how much smaller it is. The second one is the scale factor, how much smaller it is, okay? So it's 56, that's a thing, cubic or square centimeters smaller, and then 0.87 doesn't have units, that's how many times smaller it is, okay? So we subtracted and we divided. We found the scale factor and we found the difference, okay? All right, do y'all want to do volume? I don't think we need to. I think we've done volume enough. We have one more problem. These skyscrapers are square prisms with the given dimensions below. I don't know if you can see all of them. If their heights remain the same, so don't touch their height. This is, like we talked about, length by width by height. If their heights stay the same, how could you change the base dimensions of the smaller tower to make the volumes equal? So there's a lot going on here. Thanks. Let's find the volume of both of these square prisms. Let's find the volume. Length times width times height. 70 times 820. Sadly, it's a huge number, but in the real world, there are huge numbers. So, $4 million. Volume's about 4 million. Next one, 68 times 1040. $4.8 million. So the taller building has more volume. I want to make these equal. And I can't change the height of my building. So 820 is set in stone. I want to change the base. Now, we agreed to change the height. We did length times width times height. And we want it to equal, I'm going to run out of room. Okay. So now we can just solve this. I know we won't have time for Kahoot. I'm sorry. So this says x squared times 820 equals that long number. Divide by 820. There you go, Alex. Okay. So you divide that 4.8 million by 820, and then how do you solve for x? What's the opposite of squaring something? Square root. Yes. So how could you change the base dimensions? This is what it asked. So instead of the base being 70 by 70, the base would need to be, and this is rounding, we did round, the base would need to be 76 by 76. So you would need to add 6 feet to the base dimensions. Is that okay? Oh, you could do 77, I'm sorry. Yep, you could round. That's fine with me. Close enough. Yep. All right, so please try your assignment, and tomorrow we'll do our assessment.